Now we'll see some operators. Already I have explained you about arithmetic operators. Arithmetic are plus, minus, division, star, this, double star and modulus. Then we have second is comparison. Fine, comparison. So for comparison you have like another programming language, greater than, less than, greater than equal to, less than equal to and not equal to. These are the same. Fine. Then you have logical operators like another programming languages. Logical. We have now here you have to write and, or and not. That's it. These are the three. And, or and not. You also have bitwise operators. Bitwise are more needed when you do hardware programming. Okay, it is very much needed there. Okay, so it's like exactly like C only or C++ or Java. This is and, this is or, this is not, this is XOR, this is right shift and this is left shift. That's it. Exactly same like C, C++, Java. 1, 2, 3 and 4. Fine. Chalo, let's see something on these operators. Especially bitwise operator I would like to demonstrate. Okay. Now here I am writing A equal to 4, B equal to 6, C equals to A or B. Chalo, let's see what answer I am getting. First we'll see the answer and then we'll verify. Now see I am getting 6. Now why I am getting 6 I'll explain you. Now this 4, you know this 4, again I'll write A equal to 4. I can represent 4 in binary as 0010. B equal to 6. B can be represented as 0010. I hope everybody knows this, how this binary representation is there. Now if I write C equal to A or B. Now see what is happening. 0010 is odd with 00. I'm sorry, I did a mistake over here. Now I cannot rectify it. No, actually I was supposed to write here 0100. I made a mistake, I'm sorry for that. And here it is 0110. Now what happens here? See, first bit is 0. First bit is 0. So answer will be 0. At second position both the bits are 1. OR says when both the inputs are 1, output is 1. Third position is 0 and 1. So again OR will give 1. Fourth position both the bits are 0. So output will be 0 and you get the answer as 6. Now if I write A equal to 4, okay, and B equal to 6 again, and if I write C equal to A and B, now can anybody tell what will be the answer? Yes, yes, exactly 4. Very correct. C will be 4. This way the bitwise operations are performed. Okay, this is the thing how the bitwise operations are performed. You also have XOR. If I write A equal to 4, if I write B equal to 6, if I write C equal to A, XOR B. Now tell me what will be the answer. Answer will be
2.
2. Yes. Why the answer is 2? Can anybody tell? XOR operation. When both the bits are 1, output is 0.
Yes.
So here for this both the zeros is 0. This is 1, this is 1. So it will be 0. And these two bits are different. Sorry. Third bit is different. So it will be 1. And fourth bit is same. That's why it is 0. So you will get answer as 2. So I hope everybody understood why the answers are like this. Fine. So I'll just add up one more operator in that list. I missed out here in bitwise. That is XOR operation. Fine. Apart from this, Python supports assignment operators. Assignment operator. Assignment means you need not have to repeat the variable. You need not have to repeat the variable. You can have plus equal to, you can have minus equal to, you can have into equal to, you can have division equal to, okay, you can have modulus equal to, same way exponential equal to, fine. You can have bitwise and equal to, or equal to, you can have right shift equal to, left shift equal to, and many more. This is what is like other programming language supports. Fine. So let's see here. In the shell, if I have a equal to 10, I can write a plus equal to 10. Okay, I have given a space equal to 10. Now a will become 20. You can write a into equal to 2. Now a, it's 40. I can write a modulus equal to 5. Answer should be 0. Fine. In this way, Python also supports something what is called as assignment operators, and sometimes this is also called as augmented operations. Okay, it is also called as augmented operations, and Python also follows the BODMAS rule. Okay, it is also called as BODMAS, but in Python they call it as PEMDAS. Okay, PEMDAS. So it is parenthesis, exponential, multiplication, division, and then addition, subtraction. Okay, after that addition, subtraction. So Python follows BODMAS rules. So execution is like PEMDAS. P stands for parenthesis, E stands for exponential, M stands for multiplication, D stands for division. Like other programming language, then A stands for addition and S stands for subtraction. This is what is the execution rule, and association or associativity and precedence is also same like another programming language.